This is a revision class, short revision class, O-level Cambridge, motion, force, moment, momentum. Let us start from motion. Before that, you need to know vector quantity and scalar quantity. Look at this. All of you know already. Vector quantities have both direction and magnitude. Scalar quantities have only magnitude, right? Now, you need to know examples of vector quantities involved in O-level syllabus only. Look, displacement, not distance. Distance is a scalar, right? Velocity is vector, speed is a scalar. Acceleration, force, momentum, moment. Gaussian field distance actually G, right? It is acceleration too, so it must be a vector. Weight, you don't need to mention it separately. Weight is a force, so it will be a vector. All type of forces are vector, right? Now, in syllabus they introduce another quantity, though it is not in any topic. They mentioned electric field strength. It's a level topic actually. Electric field strength. It is a vector too, right? And except these base vector quantities, all are scalar. Clear? Okay, a short list of vector quantities are there. Just memorize them, accept them, all are vector. This is a simple table which illustrates some units with their quantities. You know already. This is very important, prefixes. Right? Look at this. Milli, micro, nano, pico, kilo, mega, giga, tera. Okay. If you want to remove prefix, then multiply by prefix value. If you want to add prefix, divide by prefix value. Okay. As per example, distance between sun and earth is 150 gigameter, right? If you want to express in meter only, that means you don't want this prefix, then you have to multiply it by value of giga is 10 to the power 9. Clear? Now, if you want this unit in tera now, you have to divide it by 10 to the power 12, right? Okay, now it will be tera meter. That's it. Okay, so if you want to remove, you have to multiply. If you want to introduce, you have to divide. Now next one is standard form. Look, always think that if power of 10 is not there, assume that 10 to the power 0 is here. If you want to move the point forward, then normally we give the point after one digit. So if you want to move it forward, power value will be reduced. If you move the point backward, power value is increased. So in standard form, it will be 5.6834 into 10 to the power minus 6. 10 to the power minus 6, or in two significant figure 5.7 into 10 to the power minus 6. That's it. Okay. Now, distance and displacement. Look, displacement is vector and distance is scalar. Except this, they are same. Actually, distance and displacement both are in meter. Even we use same symbol for them, right? But the direct distance is displacement. Number 2 is the displacement, and 1 to 3 all are distance. Okay, that's why displacement is vector, distance is scalar, right? They have the same unit, everything same. Only one difference is displacement is vector, distance is scalar, right? Now speed and velocity. Actually, speed is vector. Speed is defined by displacement divided by time. So displacement is a vector, velocity is a vector too. Distance moved by time is a scalar, so speed is a scalar. So speed and velocity, they are almost same. One difference is in one direction. If it is in one direction, then it is velocity. Velocity is a vector, speed is a scalar. Okay, otherwise they are same, even use same symbol. Initial speed or velocity is u, final speed or velocity is v. Clear? And is we use it for distance or displacement. We can use d also. That's it. Now acceleration, it is vector. It has only relation with the velocity only. Acceleration is the change in velocity by change in time. Clear? So it is the vector quantity. Right? Acceleration is defined by delta v delta t or v minus u by t. Now come to the unit. Displacement has unit meter. Velocity is displacement by time, so it is meter by second or meter per second. Speed has the same unit too, but acceleration is meter per second by second. It will be meter per second square. That's it. Acceleration can be positive or negative. If velocity of a body increases, that's a positive acceleration. If velocity of a body decreases, it's a negative acceleration or deceleration. For a vehicle, it is called retardation, right? Okay. Now, these are the formulas generally we use to solve equation of motion. Note one thing, all these four formulas only used for acceleration or when velocity changes at a constant rate we can use this formula, right? Mostly we use number 1 and number 4, but all are valid. You can use any of them. Number 1 actually came from v minus u by t. If you rearrange it, a2 will be v minus u. Look, v minus u. Then rearranging it, you can find it out, right? Okay. This is the formula for average speed also. Now, only for constant speed you can use this formula, s equals to vt, or speed equals to distance by time or displacement by time. Use this equation carefully because you can only use this formula for constant velocity. Okay, that's it. Now, these are the equations. Look, a car is moving with velocity, brakes are applied. If you solve this, better you collect data. Look, car is moving. The fact is not started yet. So U is 20. Formula does not know deceleration, so make it acceleration, just giving minus 4 here. Right? Okay. It goes to rest finally, so it is 0. So for number 1, use formula V is equals to U plus 80. Right? V is 0, U is 20 minus 4 into t, time will be 5 seconds. So like this. For distance move, you can use S equals to U plus V by 2 into t because you already know t. Use 20, final velocity is 0 into 5. That's it, 50 meters. Okay, now come to the next one, vertical motion. Look, if you throw something up, it will be slowing down, right? If you drop something, it will be speeding up. If air resistance can be ignored in both cases, Okay, magnitude of acceleration or deceleration will be same. When moving up, it will be slowing down, so it's a case of deceleration. So A will be minus 9.8, right? When falling down, it's a positive acceleration, it will be plus 9.8. You cannot use 10 unless it is mentioned in the question, because recently syllabus has been changed a bit. They introduced G as a 9.8, right? Actual value is 9.81. So when moving up, acceleration G is an acceleration. It's called acceleration of free fall. So when moving up, it's a deceleration, and when you throw something up at the topmost point, velocity is zero. When right. As for example, look, come to question 9. What is written here? A stone is thrown vertically up with velocity 25 meters. Okay, from the ground level, it has been thrown up. So U is 25. Always collect data. It is safer. Look, no other informations are there, but hidden information is it is moving up. So A is minus 9.8. V is 0 because topmost point of the flight, right? So how long means you need t, so v is equals to u plus 80. 0 is equals to 25 minus 9.81 into t. T may be 2.6 seconds. Calculate the maximum height. Look, if you throw it from this, it is the topmost point, so this distance moved in upward direction is h. That means h is equals to s of the equation of motion. So you can use s equals to ut plus half at square, v square equals to u square plus 2s, or u plus v by 2, any one. Okay, as a new equation, if you want to use this equation as a new one, v square equals to u square plus 2s, it will be 0 square is equals to 25 square plus a minus 9.8 into s. Just solve it. Clear? Okay. Now, if you drop something, then initial velocity is zero. As for example, look at this question of the Eiffel Tower. Look, this is S, distance of height of the Eiffel Tower, right? It is released, dropped, not thrown at all. And moving down, it will be plus g. Now use any formula you know. As for example, what will be the velocity? Okay, use u plus it. Right? Okay, how long will it take? Oh, for first one, no, you should use p square equals to square plus 2as. Right? Then for second question, okay. Look, if a body moves from A to C, this is the distance 150, but displacement will be this direct distance. Okay? Okay. That's it. Now come to next one. Motion graph. This is very, very important. Motion graph. Look, you must have proper knowledge about the graph. Every graph has an x-axis and y-axis. Look, most of the graph can be explained by mathematical equation, mathematical identity. If it is y equals to mx graph, mx means any constant, as for example 4x, 5x, 0.2x, whatever. In this case, okay, graph, if you plot it with the data, if you place data, look, x equals to 0, y 0, x equals to 1, y 4. If you plot in this way, you'll see that it's a straight line through the origin. And this spatial relation is called directly proportional. If this line does not go through the origin, it is not directly proportional. Okay, it has to be straight too. Now, inverse relation. Inverse relation means if one increase, another one decrease. If one is double, another will be half. It will be asymptotic graph. right? This is y equals to m by x. It is called y inversely proportional to x, inverse relation. Now another one is y equals to mx plus c. It's a straight line too, but the difference is it is it has a y-intercept c, right? It is not passing through the origin. That's it. If there is a square, as for example y equals to mx square, it must be a curve. If x is double, y will be 4 times high, so it will bend in this way. That's it. Now come to the motion graph. Motion graph actually in O level you need only two graphs. One is how displacement or distance varies with time, right? Another one is how velocity varies with time. Note one thing, what? Every graph has two identity, two important nature. What? Gradient and area. Sometimes gradient important, sometimes area, sometimes both. Right? If you want to know whether gradient is important or not, divide unit, right? What is the unit in y-axis? X-axis. Gradient is actually delta y by delta x. Okay, come to the gradient part. Look at this. This is a line. For gradient, you can draw a triangle anywhere like this, but bigger one gives better result. That's why, look, these are the triangle used for gradient. You can use the formula y2 minus y1 by this formula you can use it also, but easier time saving is delta y by delta x. As for example, for line 1, this is what, 18 divided by what, 12, it is 1.5. For line 2 it is, look, this is delta y and delta x. So how much is it? It is 20 by 5, 4. Look, line 2 is steeper. Its gradient is 4, it is 1.5. So steeper line has greater gradient, note one thing. Parallel lines must have same gradient. This is a horizontal line, gradient is 0. Line 6, gradient is infinity. This is a line of negative gradient, line 2. If it has downward slope, it will have negative gradient, but process is same. This is delta y, this is delta x. This line is positive. As for example, look, for line 2, this is the triangle, delta y by delta x, right? Check. I don't know. It will be 11 divided by 2.5. So gradient will be minus 11 by 2.5. Okay, because this value is what, 13. So this is the gradient thing. If it is a curve, gradient will be different at different point. If you want to determine gradient of a curve, then you have to draw a tangent at the mentioned point. As for example, if it is the target point, this is the tangent, and then delta y by delta x. Do it. Done. Now come to the motion graph again. Look, one is displacement time graph, another one is velocity time graph. I told you sometimes gradient important. If you want to know the importance of gradient, divide their unit. Y-axis unit divided by x-axis. Look, meter per second, you know it. It is the unit of velocity. So gradient of displacement time graph is velocity. Right? If it is a straight line, if it is a straight line, then it has a constant gradient. So velocity will be constant, right? Gradient of this line is constant, velocity is constant. So same constant velocity can be represented, okay, in displacement time graph as a straight line, in velocity line graph as a horizontal line, right? Okay, look at this, gradient of this line is acceleration. What is the gradient of velocity time graph? Is acceleration. It is 0 because it's a horizontal line, right? Okay. Now, if the line is a curve like this, then look at this, gradient of this line is increasing, so does the velocity. So for this, right, this would be the graph. Clear? Okay. So gradient of displacement time graph is velocity, but area of velocity time graph is the displacement or change in displacement. Clear? Area may have different shape. It could be rectangle, triangle. It may have different shape, right? And you know the formula for them. So this is okay. If it is the curve, then look, gradient. This is a positive gradient, but at this point, tangent is what, parallel to x-axis. So gradient is 0, negative gradient. Okay, 0 gradient. That's it. Now look at this. These two graphs look same, but they don't represent same type of motion. For first one, this part is representing constant velocity A. It is gradient is 0, velocity 0, so B is representing rest. C, increasing velocity or acceleration is there. D, it is constant velocity in backward direction because gradient is negative. Constant velocity in backward direction because gradient is negative, right? Look, this is downward slope. But for this one, the fact will be totally changed now. Look, this is constant acceleration instead of constant velocity. Clear? Constant acceleration, this is constant velocity. This is increasing acceleration. This is constant negative acceleration. That means constant deceleration. That's it. Okay. In exam, you need to determine the gradient and also acceleration. Okay. Now come to the point. Retardation of a car. Look, reaction time. What is the reaction time? When you are driving a car, then if you see something, any hazard or okay, some obstacle on the road that will be observed by eye, then nerve will take this signal to the brain. Brain will take some time for decision making, then will order food, okay, to order the foot to press the brake pad. So there is a processing delay. This is called reaction. So what happens during this reaction time? Actually, nothing new. Thing remains same as before because you couldn't do anything. You were thinking what can be done. So during reaction time, car usually moves with constant velocity. This is called reaction time, right? For a smart driver, it is 0.7, 0.8 second. For inexperienced driver, it could be longer, right? For someone consumed alcohol, this time would be longer. Tired people will have longer reaction time. Okay, so these are the many factors. Now, after the brakes have been applied, it is brought to rest within 5 seconds. Then 5 to 0 point is not to the scale. So it is 4.2. It is called braking time. and the distance moved during this braking time, which is actually this area of this triangle, is called braking distance. And this area is actually distance moved during the reaction time, right? And this is actually what? This is actually the thinking distance, not reaction distance. Traditionally, it is called thinking distance. But during the braking time, the distance moved is called braking distance, and total distance is stopping distance. Clear? As for example, look for this question, 0.8 is the reaction time, and 0.8 into 20, this whole area, 16 meter, it is what? Thinking distance. This is thinking distance. Clear? And the area of this triangle, it is what? 3 point. This is half into this is 2.2 into 20. Clear? This is what? 22 meter maybe. This will be the braking distance, and if you add these two distances, that will be stopping distance. Got it? Okay. Now if there is sticker tape or multiple flash camera pictures are there, look, always count the gap. As for example, in this case, two pictures are taken in 1 second. So for one pic, time taken is 1 by 2, 0.5 seconds. Now how many pictures are there? 3, 4, 5, 6. How long does it take to capture all these 6 pictures? Answer is 5 gap there. So time taken is 5 into 0.5, 2.5 seconds. Okay? Then distance by time will be the velocity. So this is motion graph and motion actually. Next topic will be this is the topic force in others, right? In the next video we shall discuss on this.